We're going to do our question about the tortoise and the hare, which is up here. The hare is going at 1.2 kilometers per minute, and the tortoise is going at 0.01 kilometers per minute in a 5K race. The tortoise has an 8-hour head start. Will the hare pass the tortoise? And how many minutes faster will the winner pass the finish line compared to the loser? So the first thing I need to do is to check whether I think this is a linear or inverse situation. And this is one of those situations where I'm looking at the slope. Kilometers per minute is one of those units of measure which is like 2 units of measure combined. Kilometers, then a slash, and then minutes. That sounds like the unit of measure of a slope. So that indicates to me this might be linear, and I'm going to try to answer the question assuming that it's linear. Therefore, we have been given the equation for the hare of y equals 1.2x. Well, this only makes sense if we define our variables, so we're going to define the variables. X equals the number of minutes, and y equals the number of kilometers covered. This is a positive slope, the 1.2. So as the minutes go by, the hare has covered more distance. It makes sense that we would have a positive slope. I also need an equation for the tortoise. And it's obvious from the information given that I expect it to be y equals 0.01x using the same variables. But the tortoise has an 8-hour head start. What do I do with that? It sounds like a y-intercept, but it's not what I'm going to do. What I'm going to do is I'm going to plug 8 hours as a number of minutes into this equation and see how many kilometers the tortoise has covered after 8 hours. But the first step is 8 hours times 60 minutes in an hour gives me 480 minutes. I don't want to plug 8 into this equation because 8 is a number of hours and x is a number of minutes. Now I've converted it into minutes. I can write y equals 0.01 times 480. And I get 4.8 kilometers. So the tortoise has actually covered 4.8 kilometers before the hare even starts. Now let's work with the hare some more. The hare has to cover 5 kilometers. So I'm going to put y equals 5 into that equation. I have 5 equals 1.2x. I divide both sides by 1.2. These cancel. X is equal to 4.17. And x is a number of minutes. The hare is taking 4.17 minutes to cross the finish line. The hare is fast. Now, how long is the tortoise taking to cross the finish line? Remember, the tortoise had an 8-hour head start, and that's all finished. The tortoise is at the 4.8 kilometer mark in the race when the hare starts. So the tortoise only has 0.2 kilometers left. I'm going to plug that into the same equation. 0.2 equals 0.01x. We divide both sides by 0.01. These cancel. X is equal to 20. It's taking the tortoise 20 minutes to cross the finish line. After the hare started, it took the hare 4.17 minutes. I have to write my unit of measure. I'll just put an M for minutes. Okay, so that means that the hare passed the tortoise. I have an answer to the first part of the question. Yes, hare passes tortoise. Why? Because 4.17 minutes is less than 20 minutes. So I can justify that with my numbers. But the second part of the question was how many minutes faster was the winner than the loser. To get that, we have to take the 20 minutes and subtract the 4.17 minutes, and we get 15.83 minutes. So now I've answered part 2 of the question. I did all of that using equations where I have a positive slope. This question can also be done where we use equations with a negative slope. And the way to do that is to change the way we define our variables. So that's what I'm going to do next.